How does TCP behave after the three-way handshake has been established? Well, during that three-way handshake, we established what is known as an initial sequence number. And that initial sequence number is going to be utilized for the sequencing purposes. And that sequence number is going to grow every time that we send our data, our bytes of information. And every time we receive an acknowledgement from the receiving station, that acknowledgement is going to indicate which bytes that particular device has received. So we're using a simple example here. We are saying that n is referring to the number of bytes. So how much credit is allowed. So we could say n equals 2,000 bytes. We could say n equals 10,000 bytes. It doesn't matter in this particular point in time. However, what is important to know is that this particular credit, this number of bytes, starts out relatively small. If you remember that the window size can be a maximum of 65,535, well, do we really want to send the maximum window size? No, we don't. Some end stations, for example, Windows, Linux, Unix, whatever, those end stations, the way they're designed by the vendors, for example, with Windows, it's Microsoft, they start off with a particular credit number. It might be 17,000 bytes. It might be 18,000 bytes. And what are they doing? They're really testing the waters. They're testing the waters at this point in time. So we start out relatively small, so we don't overload the network, we don't overload the end stations, and then we're going to increase the amount of credit based on how successful those bytes have been transmitted to the end station. So how do we know if it's successful or not? Well, based on acknowledgement numbers. So if the receiving device is constantly acknowledging every single byte we send, there's no issues, meaning that there's dropped TCP segments, so no packets are going missing, then we're going to continually grow until we can't grow anymore. However, if a problem does arise, then we have the ability to back off, meaning we can reduce the amount of bytes that are going to be sent in any given window. So that way there we can allow the network to play catch up, reduce congestion, and so on and so forth. So let's see what happens now with the receiver in our particular example. Our receiver in this case has received n. It received n plus 2. It received n plus 3. However, it did not receive n plus 1. You can see it never made it to the receiver. So since we're using TCP, our receiver says, all right, I've got n plus 2, I've got n plus 3. And remember, these n plus numbers are just a simple example here for demonstration purposes. And it realizes it's missing the in-between one. So what does it send to the transmitting station? Well, is it going to acknowledge that it received n? Is it going to acknowledge that it received n plus 1, n plus 2, n plus 3? What's it going to acknowledge? Well, notice what it does here. It says in all cases, I have received n, give me n plus 1. So the next byte of information after n. So let's say n was 2,000 bytes in size. Well, what would n plus 1 be? N plus 1 would be 2001. So give me 2001 plus whatever else would be included in your window size that you're going to be sending me. So if the window size is 2000, then I'd be looking at 2001 plus another 2000, starting at the 2001th byte, going up to 2000, up another 2000. Whew, my math's not that great right now, is it? All right. So that's what's happening here. We're acknowledging that. And it does it for every single one because it can acknowledge n plus 2 or n plus 3 until it receives n plus 1. It has to make sure it receives that. So what's going to happen now? Well, the transmitter is also going to have to make some adjustments because it sent a large amount of information here. It sent all of these. But in reality, based on the acknowledgement, the receiver's saying, hey, I only received this one right here. Ooh. Ooh. So the transmitter is going to have to back off. What does that mean? It's going to have to back off and adjust the window size and make sure that it sends less. So how much less is it going to send? Well, when it backs off, it's going to slow down. That's what it's known as, slowing down, and it halves the current credit. So if our current credit was 2,000, then we're now at 1,000 bytes that we're going to be sending. And then we're going to increase slowly based on the acknowledgments we're receiving, based on the bytes we're sending, and then we can eventually get up to a higher amount of bytes that are being sent at any given time. But just so you understand on the flip side, if the receiving station would have acknowledged n plus 3, would have acknowledged all of that, receiving all of that, then the transmitting station would have updated the credit, meaning let's send more. Everything's fine. Let's send a little bit more. Let's see what happens until we start experiencing issues. And when we start experiencing issues, then we're going to back off again. So there's this dynamic adjustment or flow of traffic that's going to be going through our networks when we're using TCP. And this is that flow control that we have. Under great times, we're going to be able to send a lot of information in one shot. However, when things start to get a little sour on the network, congestion occurs, let's say, routers or switches, their queues are backing up, and TCP segments are going unacknowledged, then we can back off. So in this case, you'll see that we acknowledged n plus 1, meaning I received n, give me the next in line, the next number of bytes in line. So even though the transmitter had sent it already, the transmitter doesn't question it, doesn't ask the receiver, hey, are you sure? Because I did send it. Are you sure? No, none of that happens. It just sends it. And you can see that right here. N plus 1 being sent again. Now look what the receiver does once it successfully gets it. Does it say, okay, give me n plus 2? No, it already has n plus 2. It already has n plus 3. So it says, give me n plus 4, which is the next amount of bits that are supposed to be sent next.